be the topic of the next clip. And here are the answers. P is 50 minus 1/2 Q. P is 1/3 Q minus 50 over 3. And if you equate the two and solve for P, you get an equilibrium price of 10, and you plug it into one of the first two equations and you get an equilibrium quantity of 80. And this brings us to determining the market equilibrium. To determine the market equilibrium, we combine the supply and demand and the mathematical descriptions of the supply and the demand function to get at the quantity where supply equals demand. And that is called the market equilibrium. And the market equilibrium is when the quantity supplied equals the quantity that is demanded, and the equilibrium price is the price that makes that happen. So it's the price at which the producers are willing to supply just that amount of units to the market that the people who demand the good are willing to buy at that price. So let's continue with the example of the previous section. There we had an equation for the demand function and for the supply function, and now we want to find out the equilibrium quantity and the equilibrium price. By definition, it's the price at which demand equals supply. So what we will do is to equate these two equations and to solve for the equilibrium price P. So setting the left equation equal to the one at the right and then solving for P, what we can do is we bring the minus 400p to the right hand side, giving us 800p, and similarly we bring the minus 800 at the right hand side to the left, so we get 2400 plus 800 is 3200, and we solve for the price, and if you divide 3200 by 800, then you will find that the equilibrium price in this case is equal to 4. And it's always good to check by plugging in the equilibrium price of 4 into one of the two equations above, and if you do so, then you will find that in both cases the equilibrium quantity is equal to 800. So that was the mathematical exposition. We can also do this graphically by combining the demand and the supply function into one graph. And we want to have the point where the quantity supplied equals the quantity demanded. And naturally, that's the point where the two intersect. And you can readily see in this picture that that is the point that is associated with a price of 4, the equilibrium price. And at that price, both the quantity supplied and the quantity demanded is equal to 800. And given that we have this very nice linear demand and supply curve, this is the only price for which it holds, the only price that clears the market. A practical example, the Food and Drug Administration in the US announced in January 2012 that it had detected low levels of carbendazim, which is a potentially dangerous fungicide, in samples of orange juice. So what we're going to do now is to play a little bit around with the equilibrium value. And one thing that you often need to do is you have a story like this, and you have to answer the question, what happens to the equilibrium quantity and what happens to the equilibrium price? Now, the first thing that you need to solve is an announcement like this. Does it impact the demand curve or does it impact the supply curve? What would you think? Now, for the supply curve, in this case, it holds that the levels that are detected were not sufficient to induce action by the Food and Drug Administration. So there's no impact on the supply. Some producers were not forbidden to bring their produce to the market. So that's an assumption that there's no impact on the supply side, so the supply function stays put. For the demand side, as this reaches the news, it's bad press and it can have a negative impact on the demand for food products. So what will happen in this case? Now, let's do this graphically. This is the situation prior to the discovery by the Food and Drug Administration, and we have our well-known equilibrium price of 4 and the associated quantity of 800. Now, the announcement arrives, and as a result, the demand for oranges decreases. And it decreases from original function D1 to the red demand curve D2. And what you can see is that two things happen. We need to reach a new equilibrium, and at a new equilibrium, the equilibrium price is lower, and also the quantity of oranges sold in equilibrium is lower than before. It reduces by 400. And this is just one example, but one of the things that you will be trained in is to translate stories, events that happen into what it means for the supply and the demand curve, whether we will have a movement along the demand curve, whether we will have a shift in the demand curve, and what are the implications for the equilibrium outcomes. So a second question that you may ask is, what determines the magnitude of the change in the equilibrium price and quantity? In the previous example, we observed that the price decreased from 4 to 3, which is a 25% decrease in the price, and the quantity demanded decreased from 800 to 400, which is a reduction of 50%. Of course, how much demand and price change depends on the shape of the demand and the supply curve. And we want to make this a little bit more precise. So there are two important parameters here. One is the size of the shift. Do we have only a minor shift in the supply and the demand curve, or a major shift in the supply and the demand curve? The other factor is the slope of the curves. So if the supply shift, then the slope of the demand curve determines the size of the change to the equilibrium price and quantity, and vice versa. So if the demand shifts, then the slope of the supply curve will determine the size and the changes to the equilibrium price and quantity. And the size of the price change is inversely related to the change in quantity. Now, this will become much more clear with an example. So this is what we're going to do. We have the following supply and demand curve, and you can see that the supply curve is similar of shape as what we have seen before, but the demand curve is relatively steep. So what you observe here is that if there's a big change in price, then the response and the quantity that's demanded is relatively minor. So the price demand is not very responsive to changes in price. Now suppose that the supply curve will shift outward. If the demand curve is very steep, then even if the shift of the supply curve is relatively large, so we have a sizable change in the supply curve here, but what you can see is that this outward shift in the supply curve, so at a given price, a lot more of projects are brought to the market, that we have a large price response, so the price decreases quite a bit, while the quantity, equilibrium quantity, only changes very minor. And why is that? Well, from the steepness of the demand curve, you know that demand is not very responsive to price changes. So you need to decrease the price by quite a bit in order to establish a big increase in demand. Which means that if you shift the supply curve such that a lot of extra units will be brought to the market at a given price, then in order for the market to absorb that increase in supply, the prices need to adjust quite fiercely. So you need to reduce the price by quite a bit in order to reach an equilibrium where the new quantity supplied equals the quantity that is demanded. Of course, other examples are there, so you can play around with this. This is the other situation. Suppose that the demand curve is quite shallow, which means that if only the price decreases slightly, you have a big impact on the quantity that's demanded. So consumers are quite sensitive to changes in price. In this case, if the supply curve shifts to the right, so at a given price, producers bring a lot more units to the market than before, you only need a small decrease in the price in order for the quantity demanded to meet the quantity supplied, because consumers are so responsive to price changes. So in this case, if the demand curve is quite shallow, then the price response is quite small, while the impact on the change in equilibrium quantity is quite large. And of course, we now had two examples where the demand curve stayed where it was and we shifted the supply curve. You can do it yourself, the situation where you keep the supply curve where it is and you change the demand curve. So we have now observed that the slope of the demand and the supply curve play a very important role in determining how the market equilibrium outcomes will change in response to a shift in either the supply of the demand curve. And it's nice if we can summarize that impact in one statistic, and we're going to develop that statistic next. So the key idea from the preceding is that if you have a shallow curve, then there's a small change in price associated with a large change in quantity demanded. And if you have a very steep curve, then you have a large price change associated with a very small change in the quantity that's demanded. And this is what we're going to formalize. So we're often interested in how consumers or producers react to changes in prices and income. And we want to develop a language for that. Now, suppose that you have the following observation. You read in the newspaper that if the price of crude oil increases from $50 to $60 a barrel, which is quite a bit of a price increase, then the demand for oil drops by 1.3 barrels a day. Now, would you be able to conclude from this message, this information alone, that the demand for oil is very responsive to price changes or not? Well, that's very hard because we lack a piece of information. And the piece of information that we lack is that we don't know what is the current oil consumption per day. Now, suppose I would give this information to you and I would tell you that the current consumption of oil is 100 million barrels a day. That will allow you to conclude whether the demand for oil is very responsive to price increases or not. In this example, a $10 price increase leads to a reduction of 1.3 million barrels, which is 1.3% of world demand. And you may conclude from that that the demand for oil is not very responsive to increases in the price. So the trade-off that you have to make here, and what you will do is you have a percentage change in the price. So here a price increase of 20% from $50 to $60, and you compare that to the response in the quantity demanded, also in percentage-wise, and you observe that the percentage change is only minus 1.3%. So a 10% increase in price only leads to a drop in demand of 1.3%, and you conclude that that's a small change. And this is what the elasticity will summarize. So elasticities describe the sensitivity of the quantity that's demanded or supplied, in the example the quantity that's demanded, to a percentage change in another variable. And that another variable may be the price, but it may be also one person's income. And because we have choices in those other variables, we also have different elasticities. One elasticity is the price elasticity of demand, which tells you the percentage change in the quantity demanded caused by a percentage change in the price of the good, like in the example that we had with the barrels of oil. This is not really good math, but it's a neat way to summarize it, that the price elasticity of demand is a percentage change with the delta here denoting the change, percentage change in quantity as in a response to a percentage change in the price. The price elasticity of demand says something about the slope of the demand curve. We can also look at the supply curve, and we get the price elasticity of supply. And the price elasticity of supply is defined as the percentage change in quantity supplied in response to percentage change in price of the good. Now, when the price elasticity of demand is high, it means that a 1% change in the price leads to a much larger percentage change in the quantity that's demanded. So relatively small price increases will induce relatively large drops in the quantity that's demanded. On the other hand, when the price elasticity of demand is low, then even when the price increase is relatively large, you only observe a very small drop in the quantity that's demanded. Now, for the different sizes of the elasticity, we have different names. So we call demand elastic in case the price elasticity of demand is larger than 1. So when a 1% change increase in price leads to a drop in demand of more than 1%, we say that demand is relatively responsive and that the demand is elastic. Then demand is called inelastic when a 1% increase in the price leads to a drop in the quantity of less than 1%. And then there's the intermediate case that we don't observe a lot in practice, where the price elasticity of demand is exactly equal to 1. And then it's called unit elastic. And then at the extreme, you have two cases where demand is perfectly elastic. It means that if you increase the price by a very small percentage, it will lead to a complete disappearance of demand. So demand then is ultimately sensitive to price changes to the extent that if you change the price slightly, so for example a price increase, demand will drop to 0. If you would decrease the price with a little bit, then the demand would increase to infinity. The other extreme is where demand is perfectly inelastic, where the elasticity is equal to 0. It means that you can do whatever you want with the price. The quantity demanded will not respond to any of these changes. So be aware that normally an increase in price is associated with a decrease in the quantity demanded. So elasticities will be negative, and that's the reason that we put these vertical bars around the elasticity here, implying that we take the absolute value. So the real elasticity is minus 1.5, but the absolute value is 1.5. Okay, so consider that we have a very small change in the price. Now, the general formula is that for the price elasticity of demand, we look at the change in the quantity that's demanded, the delta Q, over the original quantity. So this is 1.3 barrels of oil over the original 100. And we divide by the change in price, being $10 for our example with the oil, over the original price, which was identical to 50. This is the definition of the elasticity, which we can rewrite as delta Q over delta P times P over Q. where P is the original price and Q is the original quantity. And then if we take these changes in prices very small, so our delta Q becomes a very small change in quantity in response to a very small change in price, then we will write it as the first derivative. So the delta Q, delta P, if the price change is small, is equal to the derivative of our demand or supply function. So in the space with quantity and prices, we look at the inverse demand curve. So we have the P on the left-hand side being a function of the quantity. So the derivative of the demand function is equal to 1 over the slope. So in the formula, the inverse demand function is the inverse of the demand function. We take the derivative of the demand function. So the derivative of the demand function is 1 over the slope of the curve that we observe. Now, better to do this with an example. So we have the linear demand curve that's depicted here. That's the one that you've seen before. And you should not make the mistake that you conclude that every demand curve has only one elasticity. Fact is that the elasticity depends on the point at the demand curve where you are. So let's work out this example. So the slope of this demand curve is, or this inverse demand curve actually, is that if we increase the quantity with 2,400, then the price decreases by 6. And taking the inverse of that, if we have an increase in quantity demand of 2,400, then we need to decrease the price by 6. So the inverse of this slope is equal to minus 400, meaning that for a 1 unit decrease in the price, demand will increase by 400. And vice versa, if we increase the price by 1, then the quantity demanded will drop by 400. So that gives the minus 400 here. And if we're at this point, our initial quantity and initial price are equal to 0 and 6. So to compute the elasticity at this particular point, we have minus 400 times the initial price equal to 6 divided by the initial quantity equal to 0. And given that we have a 0 in the denominator, it means that our elasticity is minus infinity here. So our demand is perfectly elastic. Now, how to interpret this? Suppose that we start with a price of 6, then the quantity is 0. Now, if we slightly reduce the price, so we have a 1% drop in the price at this particular point, then the price will drop from 6 to $5.94, and our percentage change in the quantity demanded will go. The quantity demanded will go from 0 to something that's larger than 0. So, compared to the benchmark case of 0, we have percentage-wise an infinite increase in the demand because we started at a demand of 0. And that makes the elasticity of demand at this particular point equal to minus infinity. Now, if we move along the demand curve to another point, say the point here, what is the price elasticity of demand if the initial price is equal to 4 and the initial quantity is equal to 800? Now, we can use this formula. The inverse of the slope is identical to before because we have a linear demand curve. So the slope at this point is identical to the slope at this point. So the inverse of this slope is minus 400. But the only thing that has changed is the price and the quantity that we start out with. So we now start with a price of 4 and a quantity of 800. And plugging in that in the equation, we find that our demand or elasticity is equal to -2. In absolute value, it's still larger than 1. So the demand is still called elastic at this point. If we increase the price by 1%, then the quantity that demanded will drop by 2%. Now we can move further. Then halfway the demand curve, we reach the point where we have unit elastic demand, but that's only one point in the entire curve. And if we move further down, we reach the part of the curve where the elasticity is smaller than 1 in absolute value. So we reach the point where demand is inelastic. And the reason, of course, is that once you're at this part of the curve, you're at the part where the prices are small and the quantity is relatively high, which means that if you decrease the price, percentage-wise, you have a pretty large decrease in price because you start out with a small price, whereas the change in quantity is relatively small percentage-wise because you already start with quite a high quantity. So at this part, it's inelastic, and you can move further until you reach the point here. And at the point where the demand curve intersects with the x-axis, demand becomes perfectly inelastic because your price is 0. So you need a percentage-wise infinite increase in your price from 0 to something, and the decrease in quantity will be only small percentage-wise. So it's also important to notice that the demand elasticity also tells us something about how the expenditures by consumers fluctuate if you change the prices. And the expenditures are expressed as the quantity times the price. So your expenditures on oranges is equal to the number of oranges you buy times the price that you pay for each orange. And the consumer's expenditures are the revenue for the producer. So a producer is interested in increasing his or her revenues. Now, the price elasticity of demand is defined as the ratio of the percentage change in quantity divided by the percentage change in price, which means that if demand is inelastic, a 1% increase in price reduces demand by less than 1%. That follows from the definition of demand being inelastic. But if the price increases by 1% and the quantity demanded decreases by less than 1%, then the multiplication of the two must become bigger. So the expenditures on the good must rise as a result of this price increase. And if demand is elastic, then it's the other way around. Then if you have a 1% change in price, it will lead to a reduction in the quantity demanded by more than 1%, which means that the total expenditures on the product will decrease. And this information, of course, is of interest to producers. They want to know whether they are at the part of the demand and supply curve where the demand is inelastic or elastic, because that will tell them whether any price increases are likely to increase their revenues. Now, more on that in chapter 9 of the book, which you can read, but it's not very helpful for the exam because it's not part of the course. We can also do this graphically. So on the left-hand side, you have the now familiar picture of the demand curve for oranges, and the right side depicts the total expenditures by consumers on oranges, or at the flip side, these are also the total revenues for the producer. Now, we can look at the revenues or expenditures at different prices. So at a price of 6, that's the demand choke price, no one will buy oranges. So total expenditures on oranges are 0, and we are here. But now suppose that the price of oranges drops to 5. Now at a price of 5, the total demand for oranges will be equal to 400. So the total expenditures by all consumers together at this price will be equal to 400 oranges at a price of 5 each, gives us 2000, which is the surface of this rectangle over here. And we also plotted the combination over here. If 400 oranges are sold, that can only be done at a price of 5. And at that price, the total expenditures will be equal to 2000. Now remember that we're at the part of the demand curve where demand is elastic, which means that if you increase price, then it will lead to a reduction in expenditures. But here we consider the situation where we decrease price. So a decrease in price is associated with an increase in expenditures. Now, if we decrease the price further to 4, then the quantity demanded will go up to 800 and the total expenditures will increase to 3200. So this rectangle, the surface will be more than of the previous one. So we have a further increase in expenditures. Demand is also still elastic at this point. We can further decrease the price to 3, where demand becomes unit elastic, exactly equal to 1. So at this point, a 1% further decrease in prices is associated with a 1% increase in quantity demanded. So at this point, a small price change should not affect expenditures. And this holds true. It turns out that at a price of 3, total expenditures have reached their maximum value, being equal to 1200 times 3 is 3600. And if we further decrease the price, then the area will become smaller again, meaning that the total expenditures will decrease until in the end they reach the point 0 again. So far we consider the price elasticity of demand. We can look at other elasticities which are interesting in their own right, and one of them is the income elasticity of demand, which tells us by what percentage the quantity demanded changes in response to a percentage change in income. And we denote it by, we still look at demand, but now as a response to a change in income. So we have an I over here. And as we did for the price elasticity of demand, where we talked about this demand being elastic or inelastic, we have something similar for the income elasticity of demand, where we talk of inferior goods if the consumption of the good decreases when income increases. So for example, noodles, if your income increases, you may start to eat other goods. Noodles may become inferior and you might decrease your consumption of noodles. So if it's the value is positive, we talk of normal goods. These are goods of which the consumption increases with income. And if the value is positive and larger than 1, we talk of luxury goods. Meaning that if your income increases by 10% and your consumption of cars increases by more than 10%, then cars are a luxury good to you. So inferior goods, normal goods, and luxury goods. Then finally, we have the cross price elasticity of demand, which tells you by what percentage the quantity demand for a good changes in response to a price change in the price of another good. So not the good that you consider. And if two goods are complements, it means that they go together. So that may be, say, pizza and Coca-Cola. They may be complements. You combine them. It's more fun to eat a pizza with cola and more fun to drink cola if you have a pizza. So that may make it likely that if the price of pizzas increases, then not only the demand for pizzas will decrease, but also the demand for Coca-Cola. And for complements, the cross-price elasticity of demand is then negative. Goods may also be substitutes, that if one good becomes more expensive, you start to look for another good that you can consume instead. In that case, the price increase of one good leads to an increase of the consumption of the other good, and the cross-price elasticity of demand is positive. Now, to prevent confusion, we sometimes refer to ED not as the price elasticity of demand, but the own price elasticity of demand. That brings us to the conclusion of chapter 2, where we studied really the basic supply function and the demand function. And in the next chapters, we will consider consumer behavior. So how do we arrive at the demand function of the consumers? How does that relate to the consumer preferences? And in the book, it's also discussed how the factors of production lead to the firm's supply function. But as you can see, this is written in gray because we will not cover that part in this course. And the reason is that we want to free up some time for other topics like game theory and externalities, and also because the way we arrive at the supply function is more or less follows the similar mechanism as the way we arrive from individual preferences to the demand functions. So if you know the one, you are also able to do the other. That is chapter 2. In chapter 3, we will look at how consumers and producers benefit from markets, and we also consider the role of the government and what is the impact if the government regulates markets and market outcomes. Then a final quiz at the end of this clip. So suppose that the demand is given by 300 minus 3p. Determine the elasticity of demand at a price of 50